are you from starting point? So now we're going to go just a step further with this idea of distance and displacement, and we're going to look at it in terms of a position time graph, which was from that very first lab that you guys did at home, and using that to determine average speed and average velocity. So not instantaneous, this is average. This is the data from that video on distance and displacement itself whenever you saw me going back and forth in the courtyard. So instead of really worrying about all of this data, all we're going to do is focus here, how far from the starting point, because this is our displacements, or actually it is our positions. Where are you from starting point? About that, where are you from starting point? That would be your position. And then to make it into a position time graph, we're going to assume that these little data sets are going to be in time, say seconds. And so we can assume that I would have walked those 2 meters in the positive direction in 1 second, and then in the next second I went to the -1 position, and then so forth. So what does this look like as a position time graph? It looks like this. So 0 plus 2, -1, -2, +1, and then 0 again, except it's in time. And so we have 0 plus 2, so this is the plus direction, the plus sign, there we go. -1, this is the negative direction. Let's see, -2, +1, and then back to 0. So we're going to find actually the exact same numbers for distance and displacement that we did in the distance displacement video, except we're going to use this position time graph to find it. For distance, distance is a scalar, as a reminder, which means we don't care about the direction itself. All we care about is how far did we go. So from our first second, we went 1, 2 meters. Then we went 1, 2, 3 meters. Then we went 1 more. Back 1, 2, 3. And finally, 1 more. Well, in the distance displacement video, we got 10 meters. So let's see. We have 5, 3, 4, 5, 5, 5. 5 and 5 is in fact 10 meters. So we got the exact same answer with all of this information. It's just this one is in time instead of just me standing on a number line. Same idea. So now let's do displacement. This is kind of very, very busy. So here we go. So there's 2 ways that you can look at finding your displacement. The first one is the much faster way of doing it, which is you have to understand the definition. Displacement is the change in position. So your starting position and your ending position. How far are you away from your starting position at the end? Well, our starting position was 0. Our ending position was also 0. See, position is our y-axis. So what was the difference? Well, 0 minus 0 is 0. So our displacement is 0 meters, which is exactly what we got when I was walking back and forth on the number line. The other way to do it, which is a little bit more complicated, but honestly, some people prefer it because they can see step by step how you get back to that 0 mark, which is, we're going to use our directions this time. So we're going to look at each separate displacement. So when we went from start to 1 second, we went a +2 meters. Then we went 1, 2, 3 in the negative direction. See, up is positive, down is negative. Then we go one more in the negative direction. 1, 2, 3 in the positive. And then one more in the negative direction. So if we add these up, well, we've got -3, -3. That cancels out. We got +2 and -2. Looky there, 0 meters. Now, do we care which way you use? No. You need to understand it. Understand where you get distance and understand where you get displacement. So now what we're going to do is we're going to take this idea of distance and displacement, looking at it on a PT graph now, and combine it with what Ms. Tolmich was talking to you about in terms of speed and velocity. But this time we're going to look at it as average speed and average velocity. So for our average speed, by reviewing, speed is a scalar quantity. I can spell. Yeah. Velocity is a vector quantity. And so to find your d over t, for speed, you need to use the scalar, which is distance, and for velocity, which is a vector, you need to use displacement. So we're going to look at the position time graph here to see how we are supposed to do this. Make sure you take a note of what's in red and all caps and bolded, which means it's really, really important. Do not do an average of each segment. So we are not going to take segment 1 and find speed, and then 2 and find speed, and then average those numbers again. No, do not do that. Instead, it's all about these totals. All right, so here we go. Here's my graph again. This time, instead of just finding distance and displacement, we're going to find average speed and average velocity. So this is still me walking on that number line. This is exactly the same thing that I was doing before. What we need to do is find average speed. V is d over t. So since we're dealing with speed, speed is going to be distance over time. So total distance. Go. Let's see. Oh, we did this already, didn't we? Yeah. It was 2 plus 3 plus 1 plus 3 plus 1, which was 10 meters. You want to make sure, ta-da, total distance was 10 meters. Notice it's for the entire 5 seconds. And yep, so that means our time, right? So this is in 5 seconds. And so what was my average speed if I actually walked this per second? Well, it would be 2 meters per second. All right, now average velocity. For velocity, we really care about that direction. And so we need to do those positives and negatives, or we need to look at our start and our end. And lo and behold, our displacement was 0 right here. So then what is the average velocity going to be? Funny enough, the equation's the same. It's just the D and the V stand for different things. So here, this is displacement. And so our displacement was 0 meters. Our total displacement. Time was 5 seconds. Well, 0 divided by anything. Wow, that looks like SS. No, it's 5. 0 divided by anything is, of course, 0 meters per second. So does this mean that I didn't go anywhere? Just like with distance and displacement? No, it does mean I went somewhere. It just means that my start and my end were at exactly the same spot. And so my total displacement was still 0. 0.89. This was meters, this was seconds. So meters per second. Now let's do average velocity. Let's use a different color so that all this craziness doesn't get all mixed up. My favorite purple. All right, so same equation. V equals D over T. Difference here. This D is no longer distance. It is displacement. And so now we need to take into account direction. So never eat soggy waffles. So this one is going to be positive. This one is going to be negative. Go. So V equals, it's going to be positive 3 and negative 5. And that's going to be over time. Well, time is still 9 seconds, isn't it? I mean, it's still taking the same amount of time. Now we're just looking at direction with our meters. Let's see, 5 plus 3 minus 5 is going to be minus 2 over 9. So let's see, what is that? Minus 2 over 9 is negative 0.22 meters per second. And so if all we cared about was start to finish, then over the course of those 9 seconds, we went roughly 0.22 meters every second to the west. That's what that average velocity means. So now, remember the whole like red, bold, all caps. Don't average the individual pieces. Well, if we were to do that, I'm going to put this in red so that you know it's a no, don't do this. Don't do the red. 3 over 4. 0.75. And then 5 over 5 is 1. Well, if I average these two numbers together, I don't get 0.89. In fact, I get 0.875. I mean, it's close, but it's not the same. So we don't do this. No, 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 no. Well, do you want to know that it definitely doesn't work for velocity as well? Again, in red. Still the same, right? So let's see. This one is going to be positive 0.75 and then negative 1, right? That's going to be a negative 0.25, right? So this plus, there we go, plus negative 1 divided by 2. Isn't that how we average? Well, that's not negative 0.22. In fact, it's negative 0.125. Very different than negative 0.22. So again, no, don't do it. Don't find the individual speeds or the individual velocities and then average those numbers together. No. We got to do totals. So re-emphasizing here. Total distance. Total displacement over time.